Now question 3 tutorial, and it asks us to explain the filament widening molding process and list its relevant parameters and what is the advantage and disadvantage of this technique. Alright, so filament widening molding process, alright, it actually came from your lecture notes part 2, alright, page 18, alright, which is pretty familiar because it's quite recent. Alright, it's a filament widening process. Okay, you can access it from V4.2, alright, open molding, filament widening. So the filament widening is actually under the categorization of open molding. So when you start to mold your material, or you're actually molding it in the open air, open atmosphere, which is why the name called the open molding. Okay, so the filament widening, it's this already, so we know somewhat is open molding. So what is exactly the filament widening, and what are the relevant parameters of it? I'm gonna explain what we're gonna say in the words. We're gonna somewhat understand what is it all about. Alright, you don't need to know about this creel, but you need to know what is the continuous rovings. Your rovings are just some of this type of circular thing that is being rounded with threads. Alright, just like this one, okay, roving. Alright, these are your thing, and this thing comes with a thread. Alright, so when you pull, you can actually turn, and then after that this thread is being mixed with other stuff to actually do whatever you want. So the threads are being rolled into a row like that. Alright, so this is called the roving, and this continuous roving is being put inside together with this separator combs, right, where they separate each of these rovings in different point. Okay, so once you do that, alright, you feed these rollers, alright, will actually feed it into the resin bath. Alright, this resin bath over here is to somewhat surface treat it with a certain resin, alright, to protect the resins and to make it elastic and things like that. Alright, I'll not go into details, but this is the resin bath. And over here it will comes up to a nib rollers where it will somewhat roll, alright, try to roll all this so-called rovings or these fibers into this form. Alright, where this thing rotating, this is a rotating mandrel. You will keep rotate and rotate. So while you rotate, this guide over here will guide the material to wherever it is. So it's more of a computerized system. Alright, so the nib rollers over here and the guide is I believe this guide over here is a computerized system where you will move here or move here. Alright, it depends on how you want to move. Okay, so it's more on the computer issues. Alright, if you come to this picture, it's the same thing. This thing over here is a filament widening, or this process is called filament widening, and the first step is the rovings, alright, that fits the thread. Alright, you don't need to know this thing. I think is a you can say it's a separator combs, because I don't know what the hell is this. So you'll separate all the rovings, alright, and fit it into the resin bath to fit the resin. Alright, once it fits the resin already, there will be this shutter. Alright, this shutter in this context is actually called the nib rollers and a guide. Alright, so I would suggest that you remember shutter rather than the nib rollers and a guide, because it's coming from the lecturer. Alright, so it would be best if you write in terms of his languages. Alright, and then over here you'll just fit it in, and then you'll round it as a fibers. So these are all your fibers. Alright, and this is the track. Alright, this track over here, I don't know what the hell is going on, but most probably this track is to control the roving. I mean, it's to control this mandrel. This whole circular stuff is the mandrel. So once you finish filling up the mandrel, alright, this track over here will start to remove the circular thing. Alright, so you'll kind of remove this thing. This thing is removable. So after you rotate finish already, you'll take out this thing, alright, and then you replace a new rotating one, and then you roll again, and then finish already, you take out. So these things over here are being connected by a track, so then with wheels lah. Okay, so you move it out here and there, things like that. I don't know. So something for you to take note of. Alright, so these are the keywords lah. Alright, your roving, alright, your separator comb, alright, your resin bath, Separator comb is not given, but I think it's good to if you were to put it. And then shutter, alright, and then your fibers and your track. And these are the little stuff that you want to know for your diagram. So you're going to draw up the diagram, and that it explains the filament widening process. So once you draw up the diagram already, so this is the diagram, you're going to explain what the diagram use, and this is what I'll just explain. But if you want to say in terms of what the actual thing, then you can just read out this one. Okay, so the continuous reinforcing fibers are accurately positioned in a predetermined pattern to form a hollow, usually cylindrical shape. Okay, so I think it's kind of pure memorizing, but if you want to know, but after you understand the process, actually you can just write in terms of the process. Yeah, okay, just write in terms of the process. Alright, the rovings fix the fiber into a separate combs. Separator combs rearrange the windings, or the rovings, and fits it into the resin bath, when it somewhat bath it with resins. Next, the nib rollers or the shutter over here will start to feed the resin in properly into the rotating mandrel, where this rotating mandrel is connected to the track. Okay, so these are all in my form of words, but at least you get to know the thing. Alright, so let's take a look in what has been written from the lecturer, and it will be more clearer, I think. Okay, so the lecturers actually ask us to draw a diagram. Okay, there will be something like a diagram like this. Like this form, or most probably you need to know the shutter. Alright, the shutter is being given, or which is all this. Okay, and this is the shutter lah. Okay, and yeah, there isn't much of the thing, but it will be recommended if you were to do that lah. Okay, and never mind, let's continue. So the diagram is just draw, alright, and then you explain what you have just explained, alright, by your own words, or you can just memorize yourself throughout all these things. Okay, and so I've spent quite a lot of time on the process itself, and then let's go to the list its relevant parameters. Okay, so what are the relevant parameters? You can actually assess it through all this, your size, your shape, number, label, fabric, volume, fraction, resin, surface treatment, everything. Alright, I'll just put it into this picture over here. Alright, so these are the stuff. If you think about it, it is actually the same thing all along we've been talking. Size, shape, volume, label requirement, these are all very kind of like come to you, right? Quite straightforward. So whenever you talk about any composites, these are all your selection criteria, all your relevant parameters you want to take note of when you design certain stuff, and these are the things. Okay, only the difference is for the pre-prep. Alright, only for pre-prep you need time for it to cure. Alright, or you need a certain temperature for it to cure, and it has certain shelf life, things like that. Alright, which is the previous question, or the previous video we talk about pre-prep. So pre-prep got extra stuff like so-called curing temperature, shelf life. Alright, but nonetheless the parameters are generally about this form. Alright, so once you memorize this, actually it's quite straightforward already. There's also other design criteria or design considerations or relevant parameters. Alright, your shape size finishing, shape size, or your finishing, your surface finishing. Alright, loading path, where you want to load the material. Alright, which direction, which angle, your pressure, alright, at which you cure it, and things like that. I think whether is it a static or impact load. Alright, so these are all words coming from the lecturers. As you can see, the words are quite chim already. So static load are most probably, I believe, are somewhat creep or fatigue. As you can see, dead loads are static forces that are relatively constant for an extended time. So it can be a creeping, or it can be also this type of static load. As you can see, the let me crop it up. Right, it'll be easier to draw. Okay, so this this so-called this roof over here is the house, the weight of the roof will be transferred through the pillars, alright, and transferred to the ground, alright. So these are all the static load, alright, and moving loads are loads that are moving lah, okay. So these are all static loads and the impact load that we are talking, okay. And then stiffness and strength, you're gonna talk about the rule of mixture. Once we talk about rules of mixture, you're gonna come to page 33. These are all the summary, and your void estimate and your Rouse model. Your rule of mixtures for axial loading, rule of mixture Rouse model for your transverse loading, alright. And therefore you're gonna talk about all these equations that is coming up. Alright, your Rouse, where's your Rouse? For your void loading, alright, you're gonna use the Young modulus, alright, and the rules of mixture give you the Young modulus of your material, alright, because it's talking about the volume fraction of your material. These are all your volume fraction, amount of fibers you put in, amount of this is actually your VM, your amount of matrix, volume of a matrix. This is the volume of a fiber, if you remember, things like that. Alright, so the rules of mixture apparently affects your stiffness and your strength. Alright, more of the fibers will become more stiff, alright, less of the fibers will become more ductile, things like that, alright, because your fibers are mainly for stiffness, alright, while your matrix or your resin, alright, is for ductility, okay. So these are the things that you want to take note of. And then effects of environment are factor of safety, alright, how well it is susceptible to any environmental things like earthquake and things like that. You're flying in the atmosphere, is it susceptible to cold temperature, things like that. So you have to know all this factor of safety that is coming up, alright. So somewhat we have cleared away this one and the molding process, alright. Then what is the advantage and the disadvantage of this technique, alright. So let's talk about the advantage first. So the advantages is accurate, alright, because it's kind of like computerized system, as we say that over at this thing over here there will be a certain guide, alright. Your guide or this whole system, we call this the shuttle, I think, but anyway, yeah, this portion over here is more of a computerized system, and over here this is also more on the computerized system where how fast you're gonna turn the rovings, alright, because your roving is gonna be fit in over here. So how fast are you turning, alright, because if you were to turn too fast, this thing over here may crumple altogether, because the resin, this part over here needs time to actually sink inside the bath, alright, and too fast the thing may actually crumple altogether like this, alright, like I don't know how to explain lah, because yeah lah, but anyway, these are all the computerized system that is accurate, alright. So having a computer is more accurate, alright, and it produces a continuous cross-section pipes of high production rate, alright. So because if you think about it, your material, this process is mainly for a cylindrical system, because this is rotating, okay. So you can actually generate a very long piece of a cylinder, alright, very long piece, and you round, and then you can cut, or cut whatever you want, okay. So therefore it's more on the so-called ability to actually produce high production rate for a cross-sectional pipes, okay, because all these pipes are same cross-sectional. If you were to look into this picture over here, these are just a cross-sectional, it's same throughout, okay, same throughout. Hopefully this is pretty clear, and it is suitable for medium and high production. So it's over here, medium volume production, your filament widening, alright, which is at your lecture notes part 2, alright, page 6, okay. And yeah, so next is the disadvantage, alright, complexity of generating data for widening patterns. So the computer is good because it's accurate, but however you need to generate the data for the widening patterns, alright. So you're gonna test trial, because as I say, this is computerized. If you turn too fast, the rovings, the threads gonna fit in too fast, alright, and once it fit in too fast, sometimes this roller isn't turning fast. If this is not turning fast, this is turning fast, all your this part over here will be messed up, alright, because all the fibers all along will be somewhat crowded over here, and it may pose a lot of problems. So you need to know the amount of speed that this is turning and this is turning also. So these are all little stuff that you want to take note of for your disadvantage. Okay. And moreover, if you need to generate this computer system, you need to have a certain special design. Alright, you need to come up with a CAD product or whatever to design certain stuff if you have a customized design. Alright, if you want a different rolling methods. Alright, because all along if you think about it, you're actually rolling in this direction. Alright, or maybe you have a different forms. For example, you check it out, this one. Alright, for a circumferential widening, this is pretty easy. For a helical one, is slightly complicated. For polar widening, yeah, something more chim. So these are the things that we'll take note of. And different windings will give you different type of complexity. So this depends on the materials or the buyers who want to do it. So you require certain customized design. Alright, and therefore this is a disadvantage of that. And also you need time to actually cause it to dry, because once you fit in, alright, because if you think about it, you fit your rovings, alright, into the resin bath, and then you slowly fit inside the guide, fit inside this rotating mandrel, or this cylindrical stuff lah. Okay, so once you fit it in already, alright, you need time to slowly dry it, because once you for example, this is an empty rotating mandrel. So once you go over it again, you have to go over it just like that. You cannot stack onto each other just yet, until then after that you fit in over here, and then once you let it dry already, you come back here again to actually continue to do this. Then this one is finished already, you come back here and then you roll this again. So this is the here and there moving process, so that it will save your curing time also. But nonetheless, it still costs a kind of a lot of significant curing time. So therefore, you need a certain curing time for letting it to dry and things like that. So you may also go to your reading material. Alright, page 15, or actually page 17, I think. Is it page 17? Yeah, page 17. This is 16. Alright, so this most probably 17. Alright, you can actually go and read it out. Alright, but the key thing over here, as you can see, it's a relatively slow cycle time. Alright, so it take time to actually dry it. Alright, and then for machine to be utilized, so for machine utilizations are fairly low. Yeah. You know why is it machine utilizations are fairly low? If you use, I don't know. Yeah lor. Because you're constantly using the machine, then why is it fairly low? Or because is it the chances of activating the machine, because you have more time for it to dry, things like that. I don't know lah, for you to think about it lah. But this is generally the stuff that's going on. You can read it out yourself, should be fine. And I think you can just memorize this one, because over here also got talk about how the filament widening process work. Okay, so if you head back to the question, it asks you to get the filament widening process. Alright, so you can also come here to check it out. Alright, widening machine is lor. So I think it's pretty clear on over there. And yeah, design considerations. Yeah, I think these are the design considerations for you. Alright, in terms of the relevant parameters, you also need to take note your main design considerations. Okay, and I think this is it for the whole question. Alright, and in the next video I'll slightly talk about something related to the filament widening molding process. Alright, and it's in terms of the optimum angle. Alright, and the optimum angle is about 35 degrees to 55 degrees. Alright, so I don't know what the hell, but I think yeah, anyway, next video.